So my topic is about the impact of high and low pressure systems in the atmosphere and how this has an impact on weather forecasting. So first off, pressure systems are in the atmosphere, and these are regions of high or low atmospheric pressure. This impacts weather patterns, the temperature of the air, which also impacts precipitation, wind direction, etc., and like the formation of clouds, which leads to rain and snow. So the pressure exerted by air molecules at a weather station is approximately the weight of the air in a column that extends from a fixed area of the ground to the top of the atmosphere. And we'll get into this in like the cylindrical vertical air movement. So first off, vertical movement of air. Obviously we know air molecules move from an area of high to low pressure because it's always trying to like escape the high pressure. And air converges towards the center of a low pressure system, and then as a result, air also rises because of the reduced pressure. And a low pressure system is like a vacuum. It like sucks the air up and towards the center. And air with low density and high temperature, because the molecules are like moving fast, is surrounded by air with high air density and low temperature. And this causes the air to form an inward spiral. The rising of the air is the biggest reason why low pressure systems bring clouds and precipitation, because as the air rises, it cools and the moisture within it condenses to form clouds, rain or snow, which is like visible water vapor. So first off, this is like the spiral, the Coriolis effect. Okay. So in a high pressure system, this is an area of high pressure surrounded by lower pressure. As a result, the cold, dense air is surrounded by warmer, less dense air, which is the speed of the molecules. And higher pressure at its center, there's higher pressure at its center than the areas around it. And then the winds will blow away from like the middle of the high pressure. So then this results in a spiral outward, because winds will rotate clockwise north of the equator and counterclockwise south of the equator. This is called anticyclonic flow. And air from higher in the atmosphere sinks down to fill the space left as air is blown outward. On the other hand, in a low pressure system, lower pressure at the system than lower pressure at the center than the areas around it, because air with low density and high temperature is surrounded by air with high air density and low temperature. So then in this system, winds blow towards the low pressure and the air rises in the atmosphere where they meet, and this results in an inward spiral. As air rises, the water vapor within it condenses, and this forms clouds and precipitation, which is the visible water vapor, as we saw in the experiment of making a cloud in a bottle in class. So then the combination of Earth's spin and the Coriolis effect, wind in a low pressure system swirl counterclockwise north of the equator and clockwise south of the equator. And this is the example. This is what it looks like on Earth's surface. So then, as a result, in high pressure, the air sinks. This often results in a downward motion of the air, which is compressed and warmed, and this inhibits cloud formation, so you often get more stable weather conditions. With like clear skies, dry air, it's more pleasant. Because as air descends, the temperature rises and the relative humidity decreases, preventing water vapor from condensing to clouds or precipitation. But in low pressure systems, the air rises and wind moves in towards the center from all directions, because molecules move from areas of high pressure to low pressure. And then the air in the center has nowhere to go but upwards, so this creates the rising cycle. And the air cools as it rises, and eventually clouds will form as it cools from the condensation. So weather fronts produce clouds by causing air to rise when the lighter, warm air flows over the heavier, denser, cold air.